We've all had that moment, right? That sudden, awful silence when a machine you count on every single day just gives up. Well, today, we're going to get into the anatomy of that breakdown. We'll explore exactly what's happening inside your home's climate control system when it decides to quit on you.
So picture it. It's either the coldest night of the winter or the most blistering day of the summer. You are counting on that system to keep you comfortable, and then, boom, nothing. It's a moment of pure panic for pretty much any homeowner. So what's really going on behind the scenes that leads to that catastrophic failure?
And that moment, that feeling, it's something almost every homeowner goes through at some point. It's the point where this incredibly complex machine, the one designed specifically for your comfort, finally loses the invisible non-stop battle it's been fighting for years.
And trust me, it really is a battle. Your HVAC system doesn't just switch on and off, it is constantly pushing back against the outside temperature, the humidity, the air pressure, everything. This relentless stress, season in and season out, well, it's going to cause wear and tear. It's just inevitable.
Now here's the interesting part. While the problem is universal, the causes are often super specific to where you live. To really get this, we're going to look at a case study from a place with some pretty tough conditions, Ferguson, Missouri. But as we go through this, think about how your own environment is waging a similar war on your system.
So, in a place like Ferguson, you get these scorching summers and then freezing winters. That's a huge swing, and the basic physics of that temperature change is a huge factor. All the metal parts in your HVAC system are constantly expanding in the heat and then shrinking in the cold. It's like bending a paperclip back and forth over and over. Eventually, all that stress just leads to fatigue and failure.
And it's not just the heat, right? It's the humidity. In a really humid climate, your air conditioner is actually doing two jobs. It's cooling the air, sure, but it's also ripping moisture out of it. And that second job is a ton of work. On a really hot, sticky day, your AC can pull over a gallon of water out of the air every single hour. That puts a massive strain on the compressor and the drainage systems, pushing them to their absolute limits all day long.
And get this, even the ground your house is built on is part of the fight. A lot of areas have clay soil, which just loves to hold on to water. This creates a constantly damp environment around your foundation, which can really speed up rust and corrosion on any parts of your HVAC system that are in a basement or crawl space. It makes you wonder what's happening in your own backyard, doesn't it?
Okay, so with all that stress from the outside world, where do these systems usually break down? Let's pull back the curtain and look at the most common points of failure. We're going to demystify the 4 biggest culprits.
All right, let's go through these one by one. First up, frozen coils. If you've got high humidity and bad airflow, usually from a clogged, dirty filter, the moisture in the air can literally freeze right onto the coils. Your AC turns itself into a block of ice, and it can't cool a thing. Second, clogged drain lines. Remember all that water we talked about? It has to drain somewhere, but that drain line can get gunked up with algae and crud, causing water to back up, sometimes right into your house. Third is compressor failure. The compressor is the heart of your AC, and when other electrical parts get weak, it can struggle to get started. This hard start puts a crazy amount of stress on it, and eventually it just burns out. And finally, and this one is a really big deal, a cracked heat exchanger in your furnace. The heat exchanger is basically the wall that separates the air you breathe from the furnace's toxic exhaust fumes. All that expanding and contracting we talked about can physically crack that metal wall, creating a serious risk of carbon monoxide poisoning in your home.
So when one of these major things goes wrong, you are suddenly staring down a really tough and usually pretty expensive decision. Do you sink a bunch of money into repairing an old system, or is it finally time to just replace the whole thing?
Yeah, knowing when to just cut your losses is key. A lot of pros use a handy little guideline called the $5,000 rule. It's super simple. You take the estimated cost of the repair, and you multiply it by the age of your system in years. If that number comes out to more than $5,000, replacing it is probably the smarter financial move in the long run. So, for example, a $400 repair on a 15-year-old system, that comes out to $6,000, a pretty clear sign to start looking at new units.
And the trade-offs here are pretty straightforward. A repair means you spend less money right now, and it's a quick fix. But you're still left with an old, inefficient system that could break down again next year. On the other hand, replacing it costs more upfront, no doubt. But what you're buying is long-term reliability, better energy efficiency, which will save you money every month, and, of course, the peace of mind of a brand new warranty.
Now, whether you repair or replace, I have to say, this is definitely not a DIY job. There is a whole complex web of codes and standards that professionals have to follow to make sure your system is not just working, but is actually safe for you and your family.
I mean, just look at this. This is why it's so technical. A pro has to follow the International Mechanical Code for the installation itself, strict EPA rules for handling the refrigerants, they have to pull local permits, which means it gets inspected for safety, and they have to follow the National Electrical Code to make sure the wiring, doesn't start a fire. It's serious stuff. You see, a good technician doesn't just swap out parts hoping something works. They actually diagnose the problem to find the root cause. This kind of professional approach is what actually saves you money down the road, because it stops the same problem from happening over and over again.
So how long is one of these things supposed to last, anyway? Well, with good, regular maintenance, the industry average is somewhere around 15 to 20 years. But without that maintenance, especially in a tough climate, you might only get 10 or 12 years out of it. It really makes you stop and think about how old your own system is, doesn't it?
At the end of the day, your HVAC system is a silent soldier, constantly fighting a war with the elements just to keep you comfortable. So I guess the question you should be asking yourself is this: after everything it's already been through, is your system really prepared to win the next battle?